So we are now up to chapter 11. So chapter 11 deals with money. And so first off, we have simple interest. And so we have I equals PRT. Right? So I is the interest. P is the principal. How much money did you put into the account? R is the rate. And T is the time. And that number is in years. So given something like this, we have $4,000 at 3.5% for 4 years. And the question is how, first off, what's the interest on this? So I is going to be the 4,000. 3.5% as a decimal is 0.035 times 4. And this will give us an interest of $560. Right? And then the amount of money in this account, A, would be P plus I. And so this would be the 4,000 plus the 560, and so we would have $4,560 in this account at the end of that time frame. Well, let's look at another one. So this time I have, in terms of $1,200 at 2.5% for 9 months. So I is going to be 1,200, 2.5%, 0.025. 9 months is going to be 0.75, so 3/4 of a year. And this will give us $2,250, and then the amount here in the account would be the 1,200 plus the 2,250, and so we would have 1,222.50 in that account. So simple interest. So the other part they have simple interest is 2 different ways of basically doing the banking, the accounting part. One is called the ordinary method, which is based on 360 days. And then the other one is the exact method, which is based on 365 days. So let's look at this question and do our calculation using both methods. And so here I have that P is going to be 3,000. R is going to be 0.065, and T is 210 days. And I'm going to figure out the interest using both methods. So first, ordinary method. And so I is going to equal 3,000.065 times 210 over 360. Okay. And so if we do this, we end up with 113.75. Right? Now let's look at the same calculation, this time using the exact method. And so now I, this is going to be 3,000 0.065. This is now 210 over 365. And so this gives us 112.19. So slightly less in terms of that. All right. So we had up earlier that A is equal to P plus I. I could also say A is equal to P plus PRT. All I did is replace the I with my PRT. And then I could rewrite this one more time and say A is equal to P times 1 plus RT. So another way of rewriting the same thing. So basically I took the one in the red and I factored out my P and got that. Okay. Well, other thing then given problems is given that formula for my simple interest. So given I equals PRT, you should be able to solve that for P, for R, and for T. So if I solve this for P, P is going to be I over RT. If I solve this for R, R is going to be I over PT. And if I solve this for T, T would equal I over PR. So I just took that formula and solved it for each of the variables. Okay. So that is simple interest. The next section, which is 11.2, deals with compound interest. So simple interest is only paid, the interest is only paid on that original deposit, right? And that's it. So the amount you would get paid for the interest each time frame would be the same. But compound interest is something different. So compound interest, we have A equals P, 1 plus R over N to the NT. So here A is the amount, how much money would you have in the account. P again is the principal, how much money did you put in to the account. R is the rate. N is the number of times compounded. Per year. And T is the time frame, and that number is in years. So now that we get to that N, which is the number of times something is compounded per year, so you get in terms of seeing these kinds of things in the question. So you got annually, semi-annually, quarterly, monthly, and then daily. Right? So my values of N, annually, well, that's just once. Semi-annually would be twice. Quarterly would be 4. Monthly is 12. And then daily would be 365. Right? So let's look at a question now that uses that formula. So let's say now here we're going to need to deposit $3,000 at 5.2%, compounded monthly. Monthly for 4 years. And so A is going to be 3,000, 1 plus 0.05 2 over 12, right? Over 12 raised to the 12 times 4. And you plug that in, you find out that this comes out to be, rounding again, because we're talking money to the nearest penny, $3,691.96, right? So that would mean that the interest earned, the interest, I, would be given by A minus P. So this is going to be the 3691.98 minus the deposit. And so the interest earned on this was 691.98 cents. Is the interest earned on this one. Okay. So we have that equation in terms of compound interest. And again, given an equation, we should be able to rearrange it to solve for the other variable. So we're going to take this equation, and this time I'm going to solve it for P. So all I have to do is divide, and so P is going to be A divided by 1 plus R over N to the NT. Right? So we can take that equation and solve it for P. So then, using this formula, given something like this, I want to determine P if A is equal to 21,000 at 4.2% interest, compounded monthly, for 3 years. So now how much was put into the deposit? And so P is going to be the 21,000 divided by 1 plus 0.042 over 12 to the 12, to the 12 times 3. And so you plug this in and you find out the amount that had to be deposited was 18517.99. And then we have also, in terms of the annual percentage yield, which is the APY, also known as the effective interest rate. Okay. So we're going to calculate that. So the APY is given by 1 plus the rate R, 1 plus R over N to the N minus 1. So given something like this, so what is the APY? If R was equal to 4.6% compounded monthly. And so my APY is going to be given by 1 plus 0.046 over 12 raised to the 12th minus 1. And we plug that in. This comes out to be 0.0469, which will be 4.7%. So the APY will always be slightly higher than our APR. Right? So that is the compound interest stuff. And so the next section is 11.3, which deals with credit cards and loans. So you first get this from it. The approximate APR. And this is for a simple interest loan. And so the APR is given by 2 times N times R over N plus 1. Okay? So R is the rate, which we've seen before. N is the term of the loan in months. So, for example, we have an 18-month loan at 14.5%. So the APR is going to be 2 times 18 times 0.415 over 18 plus 1. And we end up, this will become 0.2747. So the APR on this loan is going to be 27.47% for my loan. Right? So in terms of loan, we want to know in terms of how much are those monthly payments going to be. So my loan payment formula. So the amount of the payment is A, which is the amount of the loan is R over N over 1 minus 1 plus R over N to the minus NT. Right? So A is the amount of money that you borrowed, R is the rate, N is going to be usually going to be 12 because you will be making monthly payments, and T will be the time frame, and that will be whatever the term of the loan will be. So let's look at a question. So given this, so what would be the monthly payments on the following? So you borrowed $14,000 at 9.75% APR for 4 years. Okay. So my payment is going to be 14,000 0.0975 over 12 divided by 1 minus 1 plus 0.0975 over 12 raised to the negative 12 times 4. And you plug that in, you find out the monthly payment for this would be $353.40. Okay. And so then we can figure out how much money do you end up paying back on this loan. So how much is paid back? And so the amount you end up paying back is you're going to pay $353.40 every month. So 12 months of each year for 4 years. And so you end up paying back 16963. 20 is the amount you pay back, and then the interest paid on the loan so the interest you paid on this thing is going to be the 16,963.20 minus the amount that you financed, which was 14,000. And so the interest paid is going to be 2,963.20 is the interest you pay on that one. And then that gets us to the last section we'll be doing in this chapter, which is 11.5. We're not touching 11.4. And so 11.5 deals with the big purchase, and that is buying the house. So 11.5 deals with mortgages. And so we get in terms of our payment formula, and we've seen this before, and this is going to be A R over N over 1 minus 1 plus R over N to the minus N T. Right? So that is our formula. We've seen it before. Typical mortgage is a 30-year mortgage. Okay, it's usually the type. The next common one is a 15-year mortgage. So common is a 30-year mortgage. Right. And then the other one is a 15-year. So let's look at this question. So we have a house that costs $450,000 and requires a 20% down payment. And then the person takes out a mortgage on the balance for 30 years at 4.23%. And the question then is, how much are the payments going to be? So how much will the monthly payments be? How much will the monthly payments be? All right. So first off, we need to figure out how much are they financing. Okay. So they need to make a 20% down payment. So first off, my down payment is going to be the 450,000 times 0.2, which is 20%. And this gives me a down payment of $90,000. Right? So then the amount financed, so the amount for the mortgage is going to be the 450,000 minus the down payment. And so we're going to finance $360,000. Right? So now the question then is, how much are the monthly payments going to be? So the monthly payments then is going to be the 360,000 0.0423 over 12 1 minus 1 plus 0.0423 over 12 negative 12 times 30. And you plug this in, you find out that the monthly payments will be 1766.77 for this. And now in terms of this loan, we can figure out how much you end up paying back to the mortgage company. And so the amount paid back is going to be the 1766.77. You're paying that every month for 30 years. And so you pay back 636,037.20. Okay. And so then the interest is going to be the 636,037.20 minus the 360,000. And so the interest is 276,037.20, right? And let me fix this, make it more like a 0. So you take out a $360,000 loan, and the interest you pay on that loan is $276,000. Well, the thing about your mortgage and your mortgage payments, you usually have other stuff that is put on there. And so a couple other things that you'll find usually that get tacked on to those mortgage payments is you get stuff like your property tax and your homeowner's insurance. So let's look what happens to my payment under the following scenario. Right? So you get the property tax bill for the year. And we're going to say this is going to be 4317.00, and then the homeowner's insurance, and that bill is going to be 1175. Right? So that means that these two come up to, if I add these up, $5,492 more. Right? And then we're going to divide that by 12. These kinds of things get tacked onto your escrow, is where they collect that extra money and they use that money to pay off these things like your property bill and your homeowner's insurance. So that number comes out to be 457.67. And that number would be tacked onto your mortgage payment. And so you end up every month you would be paying $2,224.44 per month, right? Is what you would see for this, right? And that will conclude this video.